So we're starting section 7.5 today on solving trigonometric equations. So instead of me giving you an angle and asking you to evaluate sine, cosine, tangent, I'm going to tell you that a trig function is actually equal to a particular value and ask you to find the angle. So let's say that I tell you that cosine theta is equal to a positive 1/2. So I ask you, what is theta equal to? You're just reading the unit circle backwards. So cosine theta equals to 1/2. I'm looking for x coordinates of a positive 1/2. And I figure 1 here. And I find also 1 down in the fourth quadrant. All right, so my answer would be that theta is equal to pi over 3 or 5 pi over 3. All right, and that's most of the story. We're just going to be looking at the unit circle, trying to work it backwards, but there's a little bit more to it. All right, so here I have graphed the cosine curve, and we were trying to solve cosine theta is equal to 1/2. So we could also think of this graphically. We could say, where does cosine equal to 1/2? Where does the cosine function have a y coordinate of 1/2? So you could think of it as plotting the line y equals 1/2. And then asking, where does that line intersect the cosine curve? And you can see that this method finds the same two answers we did on the unit circle, right? At x equals pi over 3 and x equals 5 pi over 3. All right, but if I zoom out, you see a little bit more to the story. Because cosine keeps repeating its shape over and over again, it's going to have that y equals 1/2 y coordinate over and over and over again. And again, this is because our unit circle cycles around. We go pi over 3, 5 pi over 3, and then we're going to get like 7 pi over 3, and then whatever this pi over 3 is down here that's bigger than 2 pi. And we can keep finding an infinite number of solutions. We can find an infinite number of x spots that have y equals 1/2 as a y coordinate. All right, but they're all going to be coterminal spots to that pi over 3 and 5 pi over 3 on the unit circle. So in your book is just going to ask you to find the two solutions, or however many solutions there are, between x equals 0 and x equals 2 pi. But we're going to keep in our mind that there's actually a repetitive, infinitely long list of all of these coterminal angles that would also solve this equation. All right, so I'm going to show you some simple techniques for solving trig equations in this video, and then we'll get to the more complicated ones together in class. So if we're trying to solve an equation, sine theta plus root 2 equals negative sine theta, we're going to use a simple technique from algebra to just get our variables on one side and our numbers on the other side. So I'm going to add sine theta to both sides. All right, so I would get sine theta, 2 sine thetas, plus root 2, and then I'll have 0 on the right. And then just like in algebra, we're going to subtract the root 2 from both sides to get the variable bits by themselves. So I get 2 sine theta equals negative root 2. And then I'm going to divide both sides by 2. So I get sine theta equals negative root 2 over 2. All right, and remember that sine is a function. It's not sine times theta, so we're not going to divide both sides by sine. We're going to think about the unit circle backwards. So we need to go to our unit circle and look at sine theta equals negative root 2 over 2. So if I think about my mnemonic device, ASTC, we're going to be looking in quadrant 3 and quadrant 4 for negative root 2 over 2. So we're going to find the angles down in quadrants 3 and 4 that have a negative root 2 over 2 y coordinate. And you should find, let's see, in quadrant 3, you're going to have 5 pi over 4. And then in quadrant 4, you're going to have 7 pi over 4. All right, and those are all the solutions that are between 0 and 2 pi. All right, so we can continue using some things that we know from algebra to help us to solve these equations. I've got 3 tangent squared theta minus 1 equals 0. All right, so I'm going to add 1 to both sides. So I get 3 tan squared equals 1. Divide both sides by 3. And I get tangent squared equals 1/3. And then we're just trying to get down to the theta. We're going to take the square root of both sides. So I get tangent theta equals plus or minus. Square root of 1 is 1. Square root of 3 is nothing special. So we get tangent theta equals plus or minus 1 over root 3. So in the last example, I had to think about my mnemonic device to say, where was sine negative? This one doesn't care if tangent is positive or negative. It just wants all the angles around the unit circle where you get a 1 over root 3 or a negative 1 over root 3. The trouble is going to be to find out what kind of angles are these. Are these pi over 6, pi over 4, or pi over 3 angles? So let's think about those 3 angles in the first quadrant. So at pi over 6, my coordinates are √3 over 2, comma a half. Pi over 4 angles around the unit circle have both √2 over 2 coordinates. And our pi over 3 angles have 1/2, comma √3 over 2. All right, so I want a √3 to show up in my answer. So I can already tell this is not a pi over 4. I just have to decide, is tangent 1 over √3 at a pi over 6 angle or a pi over 3 angle? Right, so we remember that tangent is sine over cosine. So if I'm up here at the pi over 6 angle, sine over cosine would be 1/2 divided by √3 over 2. If I do a little keep change flip, I get 1/2 times 2 over √3. And I think I've found it, right? I get 1 over √3. So I'm looking for pi over 6 angles. And I don't care if they're positive or negative tangent values. So they could be any of the 4 quadrants. So I'm just going to list all of the pi over 6 angles for the whole unit circle. So theta is going to be pi over 6 in the first quadrant, 5 pi over 6 in the second quadrant. In the third quadrant, I get 7 pi over 6. And the fourth quadrant is 11 pi over 6. All right, so you might get lots of solutions depending upon what the equation is. All right, one more example. What do we do when we run across these reciprocal functions here? I've got secant theta minus 2 equals 0. So my first step is just the one that I've been using. Get that theta term by itself, add 2 to both sides. I get secant theta is equal to 2. The unit circle runs on sines and cosines, not on secant. So I'm going to turn this statement into a cosine statement. So remember that secant and cosine are reciprocals. So this means that cosine theta must be equal to 1/2. And then all I'm doing is looking for places where cosine is a positive 1/2. See, cosine is positive in the first and fourth quadrants. So we're looking for those x coordinates to be 1/2. I think we've already done this once today. Theta is equal to pi over 3 in the first quadrant and 5 pi over 3 in the fourth quadrant. All right, we'll get to some more complicated techniques of solving trig equations when we get back together in class.